We are now on example 3 on page 321. We are still trying to construct functions. We have looked at a graph and come up with a function or an equation. We have looked at a word problem, words, and come up with a function. Now we're going to try and do the same thing, but with a table. Remember, what do we need? We need the rate of change, or the slope, and we need the y-intercept, also known as the initial value. All right, so in this problem, we have Ava, who is saving money, and we want to find and interpret the slope and the y-intercept, or find and interpret the rate of change and the initial value. So how do we find a rate of change from a table? Well, we're going to find the change in y over the change in x. So the change in x is 1 each time. The change in y looks to be 20 each time. So the change, write it over here, change in y over the change in x is 20 over 1. So our slope, or m, is just 20. Now, we have found our rate of change. How do we now come up with the initial value, or the y-intercept? Well, there's a couple ways you could do this. One of the ways is we could work backwards in our table. All right, so if I were to work backwards here and just kind of create, I know you probably can't see this too well, but create a table going backwards. And then, so if I go back 6, 5, 4, 3, this would be 2, 1, and 0. And then over here, if we're going backwards by 20, I've got 170, 150, 130, 110. This would be 90. And then this would be 70. And then this would be 50. Remember that the initial value of a function, or the y-intercept, is the corresponding value when x equals 0. So here we have found where x equals 0, and the corresponding y value is 50. So that is one way to come up with the y-intercept. We know that b equals 50. But sometimes the tables aren't that cooperative. So what is another way that we could come up with the y-intercept? Well, as we did in the previous problem, we could take y equals mx plus b and substitute in what we know. We know the slope is 20. Over here in the table, I can choose a value for x, 3, and put it here. And I can choose the corresponding value for y, which would be 110, and put it here. And then I could simply solve the problem. I know that 20 times 3 is 60. So I have 110 equals 60 plus b. I subtract the 60 so that I can get the b by itself. Got to do it on the other side. I end up with 50 equals b. So notice we end up with the same answer, just a slightly different way. So whether you choose to extend the table backwards or substitute into a slope-intercept equation, you should find the same thing. So we need to find and interpret. So we know if we were going to write this as an equation, our equation would be y equals 20x plus 50. And we know that the 20 is our rate, okay? And this is how much money that she is saving each month, okay? So this is how much money that she is saving per month. The y-intercept, this would be money that she already has. Okay? So we were able to find the rate by doing the change in y over the change in x. We were able to find the slope by substituting into a slope-intercept, the y-intercept by substituting into a slope-intercept equation. And then we were able to interpret what these values were. The $20 was how much she saves every month, and the 50 is how much she already has. Okay. Now there's a got it problem. We'll see how well you paid attention. I think it's actually at the top of page 322. Go ahead and try that one now.